Next, we'll look at question 5, slides and letters. And it just says there's a Pac-Man and one path from the Pac-Man to the goal. And on this path, there's letters which will send Pac-Man closer to the goal. And there are slides which will send Pac-Man further to the goal. So we're given the following heuristics and to determine whether it's optimal under whether the search will be optimal under certain heuristics. For the first one, for BS and ES, they encode the beginnings and ends of letters. So the first heuristic says it will be the number of the beginnings of letters, which means just the letters. However, for this one, the answer should be neither. Why is neither? Like if we are given an extreme example, a letter just connects the Pac-Man to the goal. So in this case, it only needs one step to go to the goal, and there are 3 letters. So the heuristic is large than the true cost. That's why it's not admissible. So it's not guaranteed to be optimal in this case. So, okay. For the second question, and for second heuristic, it just says if we have no letters, then the heuristic will just be the Manhattan distance, because ds will be the Manhattan distance from go to the current location of the Pac-Man. If otherwise, we have the heuristic will be the Manhattan distance from the current location of the Pac-Man to the closest start of the ladder, plus the Manhattan distance from the current location of go to also the closest letter ends to the go. So this one, because like in whatever cases, whatever letter, how many letters we have or how long the letter we have, the Pac-Man should go to the nearest letter start plus one step just to go from the letter from this end, from the start to the end, and also need to go from the end to the go. Also, it's Manhattan distance. So this one doesn't overestimate the cost. So this one can be an optimal for both cases. For question B, so assume all letters go straight up. So yeah, and the length of the longest letter is H max. So we have this heuristics. So what it says is YS, the YS is the current Y index of Pac-Man. So the distance from YS to the go is divided by L max and plus from X to go. So we have first we can have slides, but slides will only increase the cost because it needs to go further. And for H3, you can see if the ladder only goes straight up, then we use the distance from this y to this x divided by the longest length of the ladder. And so if we're given the longest length of the ladder, then it will be the shortest path possible way for us to get to the goal, plus the x distance from Pac-Man to the goal, because no ladder will send Pac-Man to the goal. So this heuristic will not be an underestimate, will not be an overestimate. So for this one, the heuristic is actually optimal for both search. So let's look at question C. And it just the CS and FS will be the list of all the squares that contains all the beginnings and ends of the slides. L max is the max letter length. So it says the first one, if we have, this means we have no letters, and this means the Pac-Man still has some chance to skip the slide. Then the heuristic will be the Manhattan distance divided by L max. And so one thing we consider here is actually it doesn't say the ladder can only go straight up. So maybe the ladder was just go this way, and using the max length divided by the Manhattan distance, maybe this will be larger than 1. So this, because of they're in a triangle, this will be larger than 1. So the heuristic is sometimes an overestimate than a true cost. So this one makes sure it will not be optimal. And for the second one, for the second part, we can see it's also ds divided by L max. And here, the minimum distance, Manhattan distance from the start of the ladder to the end of the ladder. So yeah, we should go like, if Pac-Man go down the ladder, brings the Pac-Man away, then Pac-Man should go to that slide. But there may be other ladders between the start and end of this ladder. So the Pac-Man, maybe it can take less steps if there's a ladder in between. So this should also be an overestimate. So the answer for this question is also neither.